So hey guys, we are back again with another problem. Numerical part we are going to solve, which is related to again the time response analysis of control system. Okay, so we are given the open loop transfer function, which is open loop transfer function is not it is nothing but g of s, right? Open loop transfer function is nothing but g of s into h of s, right? Now here they have already said the unity feedback that h of s value will be 1. Unity feedback is basically h of s. Unity feedback control system, which is FBCS. What is FBCS? F is something but feed, B is back, C control, and system is given by. Now what is it is given? It is given g of s value. Actually it is g of s into h of s, but they have directly given g of s because h of s is 1, because it is given in the question unity feedback. G of s is nothing but k by s into st plus 1. Okay, this is the given question. Now k, they are already talking about it in the second part, and now here we are given sub questions 1 and 2, a and b. By what factor amplifier gain k should be multiplied to that damping ratio? What is damping ratio? Zeta, to increase. Okay, it is 2 to increase. Okay, damping ratio is increased from 0.2 to 0.8, so we have to increase from 0.2 to 0.8. So by what value I should multiply the k? That is the question. Second question is, by what factor the time constant t should be multiplied? Here it was asking k, here they are asking t. Both the things are available in the transfer function itself, g of s. Okay, open loop transfer function, so that it is reduced, here increased, so that will be solving. Now first thing is that g of s is already given, so we'll write the solution. Now what is given? Given is nothing but g of s value is already given. This is nothing but k into s into st, capital T, plus 1, and h of s value is already mentioned, which is unity feedback means 1. Now we have to always remember, we have to find the transfer function, which is nothing but transfer function, closed loop transfer function, c of s by r of s. Now what is c of s by r of s? G of s by 1 plus g of s into h. Okay, 1 plus g of s into h. So can we substitute g of s value, which is nothing but k by s into st plus 1 divided by 1 plus, what is g of s again? G of s value is k by s into st plus 1 into h of s value is 1. Now we have to simplify this in order to arrive at the simplified form. So it will be k divided by s into st plus 1 whole divided by this, we can take what LCM. So it will be s into st plus 1, okay, plus k into 1 is k, whole divided by s into st plus 1. This and this get cancelled. What is the remaining thing? K divided by s into st plus 1 plus k. So this is the remaining thing. Can I multiply, open the bracket? So it will be k divided by s into s is s square t plus s into 1 is s plus k. Okay, I hope you got it. The thing is that this is the final transfer function we have got, g of s by r of s. Now we have to compare it with what? Standard second order system, because here s square came, nothing but second order. Now here second order system, closed loop transfer function of second order system is basically what it is given as. So comparing it with what? Comparing it with standard equation. Standard equation. So which is nothing but omega n square by s square plus 2 zeta omega ns plus omega n square. This is the standard equation. Now here you can observe that coefficient of s square should be 1 always, but here coefficient of s square is t. I want it as unit. That means you can just note it down that coefficient of s square should be 1. So we have to divide, we have to remove this, right? So how to remove this? We can just divide by t, so it will get removed. So divide the whole equation, that means numerator as well as denominator, with what? With, okay, so when I divide it, I'll be getting some equation, so we try to analyze that also. So everything should be divided, so transfer function becomes k divided by t whole divided by s square t by t plus s by t plus k by, this is what we are getting. Now here t and t get cancelled, so this will be our final thing, k by t divided by s square plus s by t plus k by t. Again, don't take LCM. Okay, don't take LCM and cancel t, because if you take LCM again, here t again will come, so don't do that. This will be our final simplified form of t of s. Now we will compare it with the standard equation. When you compare it, what you are trying to get? Carefully comparing this and this. Here also omega n square is there. Here also omega n square is there, which is nothing but natural frequency. Here also you can see k by t is there, k by t is there. So comparing, what we'll be getting, that omega n square value, can I write it as what? K by t. Yes, you can write. From this, can I get the omega n value? You have to just take square that side. It will become square root of k by t. So you got omega n value, correct? Now can I compare? Now s square, no need to compare, because s square coefficient is 1 only. You have to compare the middle term, so that you can get zeta value. When you compare the middle term, what will happen? Second thing, 2 zeta omega ns, you are comparing with s by t. Now from here s and s get cancelled, so 1 by t is here. Omega n value you already got, which is nothing but root of k by t. You can substitute. So it is 2 zeta into root of k by t is equal to 1 by t, right? So from this, can I get zeta value? Zeta is equal to, now everything will be shifted, so you have to shift to 2 also, and root k by k and t also, right? It will be 1 by this. Can I split? It will be easy for us to analyze, otherwise we'll directly put k, t is there, then here root of k by t will come, then 1 2 will come, right? Just shifting here. Now this, can I simplify again? Yes, you can simplify again. Carefully you have to understand here. Zeta is equal to, when I simplify this, 2 you can bring it in front. Now this part is important. T into root of k by t whole root, right? So can I just split it up? Root k by root t, right? Then t and root t, can I cancel something? Yes, you can cancel, because t you can write it as what? Root t into root t. Root t into root t is nothing but t only, right? So 1 root. Now what is remaining? Root t into k. Can I write root t into k as root kt? Yes, you can write, because if it is root 2 into root 3, you can write it as root of 2 into 3 inside the root. The same thing here, right? So the final thing will be root kt. I hope you understood the simplification part. Okay. So after this, so we have got the simplified version. So zeta value also we got. Now next, what we can do? Now they have said that we have to find what the factor of amplifier gain k should be multiplied with what we so that it will be increased, so that the damping ratio increases from 0.2 to 0.8. So we have to consider two cases where it is increasing. So we'll consider damping ratio. Already we have the formula. This you consider. We'll take up the first part of the question, sub question. Nothing but a part will be solving first. So zeta value formula we have 1 by 2 root kt. Okay. Now first we'll consider the zeta value as what? 0.2. Then we'll consider zeta value as 0. So two things we'll do together. One will consider zeta value as 0.2, another zeta value as what is 0 point, because it has to be increased. How much, by how much value we are getting, multiply that we have to see. When I take 0.2 value, what will happen? So the k value, by how much it is multiplied, by how much it should be multiplied, that means I have to consider two k values. That means I'll take here k as k1 and k as k2, because both cannot be equal, right? Hope you are getting, because something we have to multiply, both cannot be equal. Okay, so k is equal to k1, there k is equal to k2, because these zeta values are different. Now can I take the ratio of both, or first I'll write the formula. So 0.2 instead of zeta is equal to 1 by 2 root, instead of k I'll write k1t, and here also 0.8 is equal to 1 by 2 root k2t, right? That also we can. Now can I take the ratio so that I can get k1 and k2 ratio? So when you take the ratio of k1 and k2, so instead of that just divide, this mark it as 1, this you mark it as 2. Okay, so dividing 1 divided by 2, what will happen? It will be 0.2 divided by 0.8, LHS part divided, RHS part 1 by 2 root k1t by 1 by 2 root k2t, right? This you have to divide. So when you divide this thing, you have to understand this 2 get cancelled, root t get cancelled. So what is remaining then? The remaining part is nothing but root k2 by root k1. Okay, just reciprocal, because it is 1 by 1 by, right? We have taken root k2 by root k1. That means we have to understand one thing. It is 0.2 by 0.8 is equal to root of k2 by k1, I can write. Then the square root, if I shift there, then it will become square of this thing. 0.2 square by 0.8 square is equal to k2 by k1. That implies when I square this one, what I'll be getting? 0.2 square will be 0.04 and 0.8 square will be 0.64 is equal to k2 by k1, and I can cancel this point if I remove, it will be 4 by 64. 4 by 64 if we cancel, you'll be getting 4 ones are 4 16s are. So I am getting the value as what? I am getting the value as 1 by 16 is equal to k2 by k1. When I cross multiply, it will be k1 into 1 is k1 is equal to 16 times k2, right? 16 times k2. That means, in our, which was this, k1 was related to 0.2 zeta value and k2 was related to 0.8 zeta value. That means you have to, in order to increase from 0.2 to 0.8, you have to multiply the k1 value, because this is the first value. Because we are increasing from 0.2 to 0.8. This is k1, this is k2, zeta, this is zeta. Okay, so many zeta 1, zeta 2 also you can. So by what value I should multiply? I should multiply k1 with k2 with what? So k1 is equal to 16 times k2, or you can say that in order to increase from 0.2 to 0.8, I should multiply k2 with 1 by 16, because if I shift this thing this side, so k2 is equal to 1 by 16 of k1. That means you have to multiply the k amplifying gain with 1 by 16. K must be multiplied with 1 by 16. Don't write 69 come, because the thing is that we have to increase and get 0.8 value. So you have to get k2 value. So what will be k2? K2 is equal to something, right? K2 is equal to 1 by 16 of k1. You have to multiply 0.2 zeta k1, that you have to multiply with 1 by 16, so that you can get the increased value. in order to increase zeta value from 0.2 to 0.6. Finally, this write this statement, very important. If I am multiplying k with what? 1 by 6. Don't write 16 and come. Okay, this is just the first part. We have to go for the second part also. By what factor the time constant t should be multiplied? When it comes to t, again the same concept we have to apply, but this time we will consider, because here if you see the equation, here we took here t as constant, that means t remains the same. But in next case, what will happen? K won't change. We'll keep k constant and t will change. So next part, b part, again we'll divide. Now zeta value we know, we have to increase or decrease there. See again. So it is reduce what? 0.6 to 0.3. So first thing I'll take 0.6. So I'll consider zeta 1 0.6, and here zeta 2 0. And time I'll change it, which is t1. Here also time I'll change, time constant, but k remains constant. K constant. Remember, k is constant. K constant. So what will be the formula? Again zeta formula we are having. What was the formula? 1 by 2 root kt. Okay, this was the formula. Here I have to apply zeta 1. Zeta 1 means 0.6 is equal to 1 by 2 root kt. So k value remains the same. T value becomes t1. Here again 0.3 is equal to 1 by 2 root k into t2. Can I divide this two? So I'll take 3. So I'll take 4. Can I divide 3 and 4? 3 and 4, if I divide, what will happen? So it will be 0.6 divided by 0.3, the LHS part, is equal to 1 by 2 root k t1 divided by 1 by 2 root k t2. 2 get cancelled, and root k can cancel. So what is remaining? This will go up, this will come down, because it is 1 by. So it will become root k2 t2 by root t1, right? Root t2 by root t1. So what will be the final thing? That 0.6 by 0.3, you are getting square root of, whole square root I can write this one, right? t2 by t1, and square root, if I take it to that side, it will become square. It will be 0.6 square by 0.3 square is equal to t2 by t1. When I simplify this, can I get t2 by t1 answer? Yes, you can get. 0.6 square is nothing but 0.36, and 0.3 square is 0.09. Then point cancel. Now 36 by 9 is nothing but 9 ones are 9 fours are. So you're getting t2 by t1 as what? 4 by 1, right? You're getting it as what? 4 by 1. So that means t2 by t1, you're getting it as 4 by 1. You cross multiply, what will happen? It will be t2 into 1 is t2 and 4 times t1, right? Now we have to reduce, right? We have to reduce. So t2 is equal to 4 times t1. There we took what? K2 is equal to something to k1. So same concept. Here t2 came, there k2 was there. So here with what I should multiply? See, the thing is that we have to reduce the zeta value from 0.6 to 0.3. Here t1 was there, here t2 was there. So I need to get t2 is equal to something. So by what value I should multiply t1? By what value I should multiply t1 so that I can get t2? Right. So that is the thing. So by 4 I should multiply. So t must be multiplied with 4. Okay. So that to reduce to get reduced or to reduce zeta value from 0.6 to 0.3 answer. So always be remember that you have to get t2 equal to something, because you have to multiply with the t1. Here also same thing. Here you have to multiply something with k1, that is nothing but 1 by 16. So to multiply 1 by 16 with k1 so that you can get k2 value. Okay, increased value and decreased what we got. Okay.